Printed circuit boards, or PCBs, are the foundation of nearly every electronic device we use today, from your smartphone and laptop to electric vehicles and satellites. In this video, we're going to walk you through the complete PCB manufacturing process in under 7 minutes. From digital design files to a fully functional board ready for assembly, you'll see every major step in a real high-volume factory. It all starts in the engineering department. The factory receives your Gerber files, drill files, and BOM. Engineers run a design for manufacturability check to verify trace widths, clearances, drill sizes, and layer stack-up are within the factory's capabilities. Once approved, raw material preparation begins. Standard panels of FR4 epoxy glass fiber laminate are cut into production-sized panels. Any rough edges are deburred to prevent defects downstream. For multi-layer boards, which make up most modern PCBs, inner layers are created first. The copper surface is cleaned, and a thin photosensitive dry film is laminated on both sides. Using laser direct imaging or UV exposure, the circuit pattern from your Gerber file is transferred onto the film. After development, the unwanted copper is chemically etched away in an alkaline solution, leaving only the protected circuit traces. The dry film is then stripped off. Finally, automated optical inspection scans every micron of the layer for shorts, opens, or defects. This step ensures the inner circuitry is flawless before layers are bonded together. Now the layers are fused into one solid board. First, the inner layers undergo brown oxide treatment to roughen the copper surface and improve adhesion. Then, in a clean room, pre-preg sheets are manually pre-stacked between the inner cores. After that, the panels enter a semi-automated stacking system, where copper foils are added on both sides to complete the full structure. Once assembled, the stack is transferred via conveyor directly into the lamination press. The pre-preg melts and flows, bonding everything into a single solid structure. What comes out is a rigid multi-layer board, with each layer electrically isolated but perfectly connected where it needs to be. Holes are next. Using ultra-precise CNC drills, thousands of via are drilled exactly where needed for interlayer connections. After drilling, the panel goes through deburring and plasma dismear to clean the hole walls. Then comes the critical electroless copper deposition, a chemical process that deposits a thin 0.5 to 1 micron layer of copper on the non-conductive hole walls. Finally, electrolytic plating thickens this copper to 15 to 25 microns, creating reliable conductive pathways between every layer. Without this step, multi-layer boards simply wouldn't work. Once the holes are plated, it's time to create the circuit pattern on the outer layers. This process is very similar to the inner layer patterning we saw earlier, but with one important difference. Dry film is applied again, the outer circuit pattern is imaged and developed, and then we do pattern plating. Additional copper is electroplated only where needed, followed by a thin tin layer that acts as an etch resist. The unwanted copper is etched away, and the tin is later stripped off. This leaves clean, raised copper traces on the outer surfaces, protected and ready for soldering. AOI checks the outer layers, just like the inner ones. To protect the copper and prevent solder bridges during assembly, a liquid photo-imageable solder mask is applied over the entire board. It's exposed and developed to open up only the pads and via that need to be soldered. Next, white legend or silkscreen ink is printed to add component designators, polarity marks, logos, and assembly notes. A final cure hardens everything. This step not only protects the board, but makes it easy for technicians to assemble. Surface finish is crucial for solderability and oxidation protection. Options like ENIG, Hassel, or OSP are applied only to the exposed copper pads. Immediately following this, every board undergoes 100% electrical testing. We use flying probes for prototypes or dedicated test fixtures for volume production to verify continuity and isolation on every net. This ensures the board is electrically perfect before it moves to final shaping. Once electrical integrity is confirmed, the panel is profiled. CNC routers or V-scoring machines cut the large panel into individual boards, adding any required slots or bevels. Finally, our team performs a manual final inspection alongside AOI to catch any cosmetic or dimensional issues. Only flawless boards are vacuum-packed with desiccant, labeled, and shipped to customers worldwide. That's the complete journey. Over 200 highly automated steps, extreme precision down to 50 microns, and strict environmental controls for wastewater and chemicals. AIVON PCB factories produce hundreds of thousands of boards every day. Whether you're designing your next electronics project or simply a tech enthusiast, we'd love to hear from you in the comments. Which step in the PCB manufacturing process surprised you the most? If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and hit the notification bell so you never miss an episode. In the next video, we'll dive into the SMT assembly process. Thanks for watching, and I'll see you in the next one.